we are going to start talking about reflection of light from curved surfaces. So we have done reflection of light on plane mirrors and all that. We'll start talking about reflection of light from curved surfaces. Okay, so what are we going to be talking about here? We are going to basically be talking about curved mirrors. Curved mirrors, that is what we are going to be talking about. Okay, now pay attention to this explanation. Now when you talk about curved mirrors are made by cutting a spherical glass. Okay, by cutting a spherical what? Glass. A spherical glass, look at how it will look like. Sphere. A sphere is round. So if I get a spherical glass and I cut a portion of that spherical glass, then I can use the portion I have cut to now make a what? A mirror. So let me remove this part now. I have removed this part. Okay, so this is what I get. Now this curved whatever is still a glass. It is not a mirror yet. For me to make it a mirror, I have to coat either the inner part or the outer part. I have to coat the inner part or the inner part or the outer part, sorry. So remember that a mirror has a reflective surface. So what happens? After cutting that spherical glass, if I decide that I want to coat the outer part, okay, so I painted the outer part so that the inside becomes the reflective surface. This is the reflecting surface. Okay, now because the inside is the reflecting surface, this type of mirror is known as a concave mirror. This is known as a concave what? Mirror. So this is a concave mirror. If we don't call it a concave mirror, we also call it a converging mirror. So take note of that. So a type of mirror where the reflecting surface is inside while the coated surface is outside is called a concave mirror or a converging what? Mirror. Now what else? If I bring that glass and decide that I don't want to coat the outer part, I want to coat the inner part. Now if I coat the inner part, it means that the outer part becomes the reflecting surface. So here now becomes the reflecting surface. Okay, now if this is my reflecting surface, because the outside or the outer part is the reflecting surface, this type of mirror is known as convex mirror. It is known as convex mirror. Or if you don't call it a convex mirror, you will call it a diverging mirror. You will call it a diverging what? Mirror. So these are the two types of mirrors that we have. We have the converging mirror and we have the diverging mirror. The converging mirror is also known as concave mirror. And then the diverging mirror is also known as the convex what? Mirror. So next thing we are going to talk about under this, we are going to introduce ourselves to some important terms that we are going to be hearing whenever we talk about convex or concave mirror, or generally curved mirrors. So let's look at those important terms. The first term we are going to hear or always see is something called the what? The poles. We'll talk about the poles. Okay, so when we say the poles of a mirror, basically it means the center of that mirror. The pole of a mirror is the center of that what? Mirror. That is what the pole of a mirror simply means. So if we look at this, we said that the pole of a mirror is the center of that mirror. So what does that mean? Remember, what type of mirror is this? Yes, it is concave. So this guy is concave. So look at here. This is the center of the mirror. If I have this mirror, let me say I draw a mirror like this and I shade here. What type of mirror is this? This is convex. Beautiful. So here also, both of them are known as the poles. So the center of any mirror, whether plane mirror, okay, I forgot to tell you that about that under plane mirrors, but the same thing is applicable here. So whether it is plane mirror or curved mirror, the center of any mirror is called the what? The pole of that mirror. The next thing we are going to talk about there, the next term, that is the number 2 important term we need to know about, is what we call the principal axis. Principal axis. we'll talk about the principal axis. So when we say principal axis, what are we talking about? So if I have a concave mirror, this is my concave mirror, and I have my pole. Remember, pole is the center of the mirror. Now, a ray of light that passes through the pole of the mirror is known as the principal axis. So we are going to be seeing a lot of this. This is called the principal axis. This is called the principal axis. This is called the what? The principal axis of that what? Of that mirror. Principal axis. So that ray of light that passes through the center of that mirror or through the pole of the mirror without getting reflected, very important, is called principal what? Axis. So the same thing is applicable if it was a convex mirror. That is term number 2. Now, the next term we are going to talk about, which is term number 3, is principal focus. Principal focus. Principal focus, usually represented by capital letter F. So take note of that. Whenever you hear principal focus, it is represented by capital letter F. Now, let's define out before we start explaining it. When we say principal focus, it is a point on the principal axis, okay, where all rays close and parallel to the principal axis converge or appear to converge after reflection from the mirror. Let me go again. I said that the principal focus is a point on the principal axis where all rays close and parallel to the principal axis converge or appear to converge after reflection from the what? Mirror. Let me show you what that is talking about. So if I have a mirror now, this type of mirror is a what? A concave mirror. What did we say we call this line? Principal axis. What did we say we call this dot? Pole. It is called the pole. Beautiful. Now, looking at the mirror I have here now, I want to talk about what is principal what? Focus. Remember, for a concave mirror, the reflecting surface is here, like this. So if light is coming, look at this. This is our light ray. So let me use this line to represent light rays. Remember, I told you that this concave mirror is also known as converging mirror. So what is a converging mirror? Converge means to bring together. So when light falls on this mirror, it converges it, meaning it tries to bring it what? Together. It tries to bring it together. So what do? We converge it. We bring it close. We bring it together. Okay? So the ray of light converges at this point. So you see that after it reflects from the mirror, look at where it converges. It's coming to that spot, meaning that the mirror is trying to bring those rays of light to a single spot. And because of that, that spot where it brings that ray of light to is what we call principal focus, represented by capital letter F. So principal focus is the point where it converges. Now, for a concave mirror, principal focus is real because the rays of light actually what? Converge. Let's see what happens in the case of a convex mirror. So for a convex mirror, look at where I quoted, then I draw my principal axis. Now, look at these rays of light. Look at these rays of light. Remember, the convex mirror is also known as what? Diverging mirror, meaning that it will scatter the rays of light after reflection. So you see, after reflection, it scatters the ray of light. Look at this. The rays of light are scattered. They are scattered. But on the other hand, if you trace this ray of light back with dotted line, if we trace it back with dotted line, trace this one with dotted line, it will be as if this scattering of rays of light are scattering from this point. This point is also known as principal what? Focus. Principal focus. But pay attention. That is why we said that principal focus is the point where the rays converge or appear to converge. In this particular diagram, in the first diagram, they converged. In the second one, they appear to what? Converge. So make sure you know the one that you are defining. If you are defining this one, you should know that it appears to converge. This one, it converges. Okay? That something is appearing to converge does not mean that it converges. So make sure you take note of that. And then another point is that for this convex mirror, you notice that F or principal focus is behind the mirror. Take note of that. It is behind the mirror, but principal focus for a concave mirror is in front of the mirror here. So here is in front of, because remember, here is the reflecting surface. This one, the back is the reflecting surface, but it is here. Look at where the principal focus is. Okay, so take note of that. Now let's quickly talk about the next one, which is what? Focal length. Focal length. Focal length is represented with small letter f. So if we see small letter f, it represents what? Focal what? Length. Now focal length is the distance between the principal focus and the pole of that mirror. That is what focal length is. So if I say focal length of a mirror, what does it mean? It is the distance between principal focus and the pole of that what? Mirror. So imagine we have this. This is our principal focus. This is our what? Pole. This is our pole. So the distance between these 2 points is our small letter f, focal length. The distance between this point and this point is our small letter f, focal what? Length. That is what focal length is. That is term number 4. Now the next one we'll talk about is center of curvature, which is term number 5. We'll talk about center of curvature. Center of curvature. Center of curvature. So let's talk about center of curvature, usually represented by letter C. By letter C. So center of curvature is the center of that sphere from where we cut that mirror from. What does that mean? It means, remember I told you that for you to make a curved mirror, you need to bring a spherical glass, that is a round glass, and you cut it. You cut a portion that you need. So now that round glass or that sphere, it has a center. The center of that sphere is what we call center of gaining now, curvature. So it is the center of that sphere from which you cut that mirror from. Center of curvature. Okay, that is that. Now number 6, very quickly, which is radius of curvature. Radius of curvature. Radius of curvature. It represented by small letter r. So whenever you have center, you must have a radius, because this is round. So radius, of course, is the distance between center to the circumference. Okay, but that is not how we define radius of curvature. We said that radius of curvature is the distance between center of curvature and the pole of the mirror. Remember, if I do this, this is the pole of my mirror. Okay, so the distance between pole of my mirror and the center of curvature is my radius of gaining now, curvature. And you should know this formula, that radius of curvature is 2 times f. 2 times f, very important. Radius of curvature is 2 times f. What does it mean? It means that if I tell you that focal length is 12, for example, what will be radius of curvature? 24. Beautiful. If I tell you that radius focal length is 15, what is the radius of curvature? 30. Very beautiful. If I tell you that focal length is 30, what is the radius of curvature? 60. Beautiful. Now what if I now tell you that radius of curvature is 40? What will be focal length? No, that's not true. It is what? 40 divided by 2, which will give you what? 20. Okay, if I tell you that radius of curvature is 20, what is the focal length? 10. That is nice. If I tell you that radius of curvature is 25, what will be focal length? 12.5. Beautiful. Now, so you should know how to convert between both of them, but you should always remember that formula. The radius of curvature is 2 times what? Focal length. Okay, so the next thing we are going to look at is we are going to look at how to actually solve questions with the mirror formula. So we'll talk about the mirror formula in the next session.